Okay, folks. Good afternoon, good morning, good evening, and good night, wherever you are. This is Paresh Motiwala from Houston, Texas, in USA. It's my pleasure to be the moderator for the past three sessions. This is my last session, which is also the last session for the entire conference, which was absolutely fabulously held. Thank you to Jean and Ronan and all other lovely team members and the great speakers that we had today. So do join their conference team, see if you can help them out. I would definitely join. I have already let Ronan know about it. Hopefully I can connect with you guys someday soon. Cool. And of course, conferences are not possible without sponsors. So gold partner being Stream, bronze being Packet and Redgate, or Packet is Redgate, I don't know. Silver is Power BI Sentinel, and Exelegent and Q Associates. So thank you so much for the sponsors for doing this awesome stuff. And please hang on after the sessions are over. There's a lot of prizes being given away. If you scan the entry or you registered there, this may be a good time for you to go back and check out and see if you can register. So without much ado, let me introduce Mark Kromer. Actually, this is my first time meeting him, so I cannot say, yeah, here's my good friend, but now he is.
Okay.
So, so thank you so much for doing this. I was always under the impression this is something to do with DQS and master data and all that, but
If I were
ADF
given
is the
this
way to
10,
go.
if I were given this 10 years ago, it would be, yeah.
Yeah, exactly.
I
But I think he's like Microsoft's program manager for ADF, which is awesome.
am.
I would invite you to speak at our Boston BI user group virtually, of course.
Anytime.
And
Happy to.
yeah, and cool. So thank you so much. And without much ado, I'm going to make you the presenter. I think you are already the presenter, so I just need to stop sharing. But
Okay.
guys, do give your feedback on the sessions quickly enough, and saying goodbye for this one last time as the moderator of these sessions from Houston, Texas. Thank you, guys. And I'll be on mute. I'm looking for any questions, comments, or anything that pops up. I will share them with you. How would you like to handle those questions, Mark, as they come
I'm
along?
Yeah, I'm happy to answer as we go along. I don't mind that at all. Feel free to do that. If yeah, I'm probably gonna have some time at the end, but I do have a lot to cover. So let's just do it as we go. If there are questions, just jump in and let's do it that way.
Okay, or I can just sweep them under the carpet. That's okay. We can do that too. No
I
worries.
definitely want to answer them, but I don't think we have to save them for the end. Happy to answer it while we
Yeah,
go.
makes sense. Okay, cool. So I'll go on mute now, but I'm watching the chat and I'm also watching
Awesome.
your awesome session. Thank you, sir.
Yeah, thanks for doing that. Thanks. Great job with the emceeing it, and thank you to everybody involved in this session and in the conference. This is fantastic. I love it. And thank you for inviting me. So that's right. So I am Mark. I'm a principal product manager. By the way, we kind of waffle between program and product manager at Microsoft, and we've actually started to go toward saying product manager now. So it's the same role. Just if you start to see us listing ourselves as product managers, that's still program managers, but we're using a slightly different terminology, just kind of changing the taxonomy and the product teams a little bit here at Microsoft. So the team I'm in is called Microsoft Data Integration, and I focus on Azure Data Factory. And I've been with the Data Factory team now for a little over 5 years. And in the bio at the during the intro, you did see that I've worked in the ETL and data base space for a long time with a number of different companies like Oracle and Pentaho and whatnot. And yeah, so I've been with Microsoft for about 12 years. And what I'm going to talk to you today about is how to build data quality rules and data cleansing in your data pipelines. And so in Microsoft, when you're building a data pipeline, it's going to be in Azure Data Factory, cloud first, and it's ETL data integration in the cloud. Now, unfortunately, because I have an hour, I'm not going to be able to go into detail in terms of getting started with Data Factory. And I get this a lot when I present on very specific areas of data pipelines and Data Factory. In this case, I'm going to focus on data quality and data cleansing. I get that, sort of a lot of times, there'll be, can we have a little bit more background, a little bit more intro to Data Factory? And absolutely, we've got tons of material online. We have an awesome YouTube channel. If you go to YouTube, you'll see Azure Data Factory, our own channel there. We have a lot of good material on there. And of course, we have tutorials online. So unfortunately, I won't be able to get you in that sort of starter mode, but there will be some assumption that the things that you're going to be learning and talking about today will have some understanding of Data Factory. I'll try my best to kind of give at least a cursory talk to what the different areas of Data Factory are that I'm using, so that it's not completely out of the blue for you. And like we said earlier, please jump in with questions as we go. Happy to stop and answer. So first thing I want to do is I want to talk about, before we go into the tech and into how you can do these things in your pipelines, what do we mean by data quality for data warehousing scenarios? I have two different scenarios to focus on today. The first is data warehousing. Now, when you are building ETL jobs and data integration for data warehousing, there's a number of different challenges that you're going to be faced with in terms of data quality. The first one is, and there's more than just this, but these are sort of the primary things we're going to talk about today. First one would be how to deal with data types and lengths, and how to verify those data types and those lengths of the data. And this is important because if you don't build into your pipelines capabilities around resiliency for things like changing data types or changing data lengths, then your ETL job and your pipeline becomes brittle. And so Data Factory has a number of facilities built into it called schema drift and ways to handle metadata and metadata checkers. And I'm going to show you how to do that today. The second one is how to handle nulls. And nulls are very important because when you are loading data into your data warehouse, you really need to be loading data that is actual factual data and data with meaning behind it. And loading nulls is not actually something that you really typically would like to do. So you need to think of ways of how would you like to handle those null values and present those null values to the reporting users. And we'll talk about how to make decisions on that. Domain value constraints. I just put a very simple example of what I mean by that, which is US states has a specific set of values within it. And so you can set rules, data quality rules, that say that if anything is outside of this value range, this domain range, then it is an invalid record. And what do you do with that invalid record? I'll show you how to log those and tag those rows. The next one is how to get to a single source of truth or master data. Now, I'm not really necessarily going to talk today. In fact, I'm not going to talk today about how to really go into depth on master data management. But instead, I just want to talk about the fact that you're going to have in data warehousing, in ADF, we are a cloud-first data integration ETL tool, which means that we're going to talk about loading data in a cloud-first and big data scenarios, which is sometimes has different challenges than you might have faced, although similar, but slightly different challenges, new challenges that you'll face versus the traditional on-premises data warehouse ETL that you've built in the past. And one of those can be that you're going to have data that's going to be not just even messier and less clean than before. I mean, gosh, we've always dealt with ETL for a long time in the data warehousing space, that the data is just not coming to you in a clean state. But it gets even worse in the lake, in the cloud. So how to find that single source of truth, and what is if you're finding similar values but not exactly the right value, what is the one to pick? What is the source to pick? The other two are very important when you are building the schemas on the data warehousing side. First one is what's known as late arriving dimensions. So when you're building dimension tables, you're going to have values that come in that you need to load into those dimension tables that may not be present yet. So you're going to get a fact that you need to log into your fact table, but it doesn't have a dimension for it. So we have mechanisms within Data Factory within our templates to allow you to handle fact loading with late arriving dimensions. It's a very important problem to solve. And the last one that I put on the chart here on the slide here is reference data lookups. So not only lookups for surrogate keys in terms of dimension tables, but also how to look up data from other sources to enrich the dimensions and the facts that you're loading into your data warehouse with reference data, and how to do that in a lake. Again, the lake is very messy, and so I'm going to show you how to do fuzzy lookups to solve that problem in Data Factory. Now, the other scenario I'd like to talk today about is data quality for data science. And a data science scenario has similar but again slightly different challenges. Now, deduping of data, the first one I have on here, That's going to be common in all scenarios, to be quite honest with you. But it's maybe a little bit more important in data science if you're going to be providing statistics and modeling that data in a way that can help you to make business decisions. And deduplicating that data can help to eliminate decisions that are made on bad data, which is at the end of the day what we're really trying to solve here, this problem. So I'm going to show you how to dedupe data very easily in Data Factory. Descriptive data statistics, extremely important in the data science scenarios. I find ETLers, those of us who have built ETL pipelines and packages in the past, that descriptive data statistics is very important, even in those scenarios as well. But it's very highly used in data science scenarios to find, what is the length, the data type, the mean, median, and so on for columns. I'll show you how you can do that. What is the frequency distribution? How are the values within a column or an attribute distributed? And again, how do I handle missing values? Not nulls. Notice I didn't say nulls because nulls is much more of a database construct. Missing values is more of a data collection problem in data science. So as you're collecting data and you're building your target models, what do you do with missing values? Do you just leave the missing value there? Do you present it as null? Do you make it 0? Do you maybe use an average of the other values within that range? Or do you use a median value and replace with that? Decisions that you would have to make in your pipeline. Enumerations are turning codes into categorical data. So if you get something, I should have put an example on here, but let's say you got something that comes in as like, I did this example on a blog, I think it was last year for ADF, where I said that I was doing some soccer stats. And when we were collecting soccer stats, I know another example. We did this for basketball statistics as well. In those cases, you would get stats coming in from the groups that would maintain all these sports stats, and something like let's see, I don't know soccer really well, so let's say a kick that went out of bounds, or in the NBA, if it was maybe a 3-point shot, the data coming is not going to say 3-point shot. It's going to have a code like the shot type was a 3. Right? And then you translate that into a categorical data, which is something you sometimes need to have in the model, or you could go vice versa. You could switch, and I'll show you how to build case statements to do that. The last is value replacement. So if there's some bad values in your data, do you remove the row, or do you replace it with, again, an average value or a value that's more within the standard deviation? And you can, again, you have to make a choice on that as the ETLer and as a data integration expert on what to do with those. These are all the problems that the challenges that we face. If you, like me, have been in this data engineering space for a long time, then this should be new to you. I just kind of want to lay the framework and the groundwork for what are some of the problems that we face that we're going to try to solve in Data Factory today. Let me go through a couple more slides, and then we'll spend the second half of this session completely in the tool in Data Factory. So the first thing we want to talk about is replacing values. Now, if you want to do something to replace an empty string, replace a null with actual values, or replace missing measurements with aggregates. Those are 3 great techniques to use to replace values. The way you're going to do that, and the example I have on the screen, is using the activity type in Data Factory known as a data flow. So those of you coming from the SSIS background will be familiar with the difference between control flow and data flow as well. In Data Factory, the same split exists. And control flow in Data Factory is known as a pipeline. And data flow in Data Factory is known as mapping data flows. And what I'm showing to you is the set of, on the right-hand side is the set of transformation primitives that are available to you as a data engineer inside of Data Factory data flows. And so what I'm doing here is I'm taking a derived column and an aggregate. Again, those are the same transformations that exist today in SSIS as well. So the derived column would let you use that first code example of if length of title is 0, then give me a string null. Otherwise, give me the actual title. The reason I'm doing this is I'm being defensive here, right? And I'm saying that I don't want you to put a null in my data science model or in my data mart that's being used by data scientists. I want to replace that value with a 0 if the length of the title is 0. That's how you know that the title had no value. So I'm going to just put a string representation of a null in there. Now, if you want to replace nulls with values, that's the second one. So you're going to say if the customer name is null, then I'm replacing it with NA. And you'll figure out whatever code you want to put in to your columns or your values based on the standard that you choose. And then, of course, if customer name is not null, then use the original customer name. The last one is I want to replace missing measurements with aggregates. So I'll use the aggregate transformation. The aggregate transformation, I have an example at the bottom in the middle of the slide where I'm saying that I'm going to use the average rate, which is using average of rating to decimal using the precision of 10,2. So this language, this is the data flow, data transformation syntax and language within Data Factory. So what I'm doing is I have a missing measurements in my data, but I'm not going to just put 0 in there or delete that row altogether. I'm going to use the average, some smoothing based on that, okay? All right. Now, another example. Splitting data on values. This is very important for a couple of reasons. One of them, back to the data science scenario, is if you want to provide data into the lake or into a database table for your data scientists to have first the data to train the model and then the data to test with. So you can split the data and then give them two different sets of data to both test and train with. And you'd use what's known as a conditional split. Again, the same terminology that comes from SSIS is available to you natively in Data Factory. And so I'm going to use, in this case, I'm using conditional split to split on movies that were before movies that are in 1980 and the movies that came after 1980. I'm not exactly sure why I'm splitting on that, but that's what I'm doing there just to show you as an example. The other thing you can do is you can actually completely replicate and duplicate your stream of data in Data Factory at any point using what's known as a new branch. And the new branch is the same as in SSIS, I believe it was called the whatever they called it. It would actually create multiple streams of the same data. A multiplex, I think it was called, or something along those lines that we added a little bit later. So that's the conditional split. Now, the way to set conditions for the split are at the bottom on the left-hand side, where I'm saying that if the product ID is null, then I'm going to send that down to the bad schema. I have this example in my factory I'll show it to you in a few minutes, down the bad schema route. If not, then everything else is considered a good schema. What I'm doing there is I'm doing some schema checking. So the by name function is a function in Data Factory data flow that will say, find any column in my schema, my incoming schema that's called product ID. If there's no value for that, then this is a bad schema, and I don't want to process it. This is a metadata, a schema checker. Okay. Let me see if there's anything else I wanted to say on this. I think I had all the bullets on that one. That's conditional split, and that is new branch in Data Factory. Now, I talked about the profiling stats earlier, and how do you profile your data and get insights into the shape and the size of your data, and that's your data profiling. Data Factory gives you two really good ways to do this, and essentially whichever one you use is really kind of a matter of preference. Then I have a link at the bottom there. I'll make sure these slides are available on my blog and on my my Twitter, and I also have a slide share that I can share the slides with. So you can get that link, or you can just look at the link at the bottom is actually coming from our ADF Tech Community blog. So the Microsoft Tech Community blog, look for Azure Data Factory and you'll see that blog. What I do in that blog is I show you how to take your data's profile stats and how to persist those, put them into a data store or into the lake. Now notice the top screen at the right-hand side is actually Power Query. So remember, I said earlier that the team I'm representing here today is Microsoft's data integration product team. We have both Power Query and Data Factory in our same team. We also have SSIS in our team as well. So all the data integration products are under a single umbrella called Microsoft Data Integration. So we're working really hard to sort of lessen the differences between these tools going forward, so you can have a single pane of glass and a way to operate between these different tools that really feels and looks the same. But what I am showing you is that in Data Factory, you're going to have two ways to profile the data. The top right picture is Power Query. That's built into Data Factory. You add an activity. I'll do this for you today. You add an activity onto your canvas, the Power Query activity, and you can, using the Power Query online capability, it will take your data set from Data Factory and it will give you the descriptive stats of your data, just like you see on the screen there. The bottom right is inside a Data Factory and I'm building a pipeline. I opened up the data flow capability and I looked at the profile stats there. And here I'm seeing the distribution of values. I'm seeing some descriptive stats around number of nulls, maximum length, and those things. So the lengths, the number of nulls, the value distributions. The value distributions above in Power Query is given to you by the chart, the inline charts, and all extremely important data to know about what the data is that you're working with. Now, coming back to the concept of the data in the lake, when you're working with Data Factory in the cloud, it's going to be very messy, maybe messier than you're used to. And so to account for that, we have built-in facilities like schema drift and this that you're seeing on the screen, which is pattern matching. Rather than have to build transformation logic that addresses column names distinctly by those column names, we're allowing you to build patterns. In the cases I have on the screen, they're fairly simplified examples just to kind of help you grok the concept. You see that on the left-hand side, I'm saying any column that is a type string, I want to trim it. Any column that's of type integer, I want to make it into an integer. Oh, I'm like wondering why I'm actually doing that is because I'm creating a new field. The bottom left column is saying int underscore plus $. $$ is syntax and data factor that represents the current value of that column. So I'm saying anytime you find a column of type integer, make a new column called int underscore that column. So what I'm getting at is here, I don't need to specify columns by name. I can use by type. On the right hand side, I'm saying ordinal position. Any column between position 1 and 25, I want to average it. It's very powerful, right? Because now you can have logic that is easily repeatable and logic that is not brittle. This will not break because somebody on my source data generator changed a column name from customer to customers. If you're actually looking for the column customer, that ETL can break the next time you run it because that column is no longer present. Another thing you can do, which is really powerful here, is in pattern matching. You can actually use the column, reserved word called name in Data Factory. Name will actually give you the column name, which means I can do regular expressions and I can do like. I can say if name like customer, then transform the data in this way, which means that if somebody changes it to customers or customer X or customer Y, it becomes a resilient pipeline. Extremely important for data quality because you cannot guarantee what your data is going to look like from run to run. All right, the next one I'm going to talk about is those enumerations lookups that we mentioned earlier. So actually, I use as an example. Oh, I did use my soccer example on the top right. So what we're doing here is we are translating codes into categorical or what's known as string data, right? And I'm using a case statement. Case statement is available in data flows and Data Factory. And this is a way to do it. Another way to do it is do a lookup, right? So the bottom right is a lookup example. I could have coded or I could have designed the top right enumeration as a lookup and say, give me a table that has a column called event type, or the event type could have been maybe the primary key. And then the string, the announcement, attempt, corner, foul, so on and so forth, could just be the name of that event or the event name. That's another way to do it. I think the lookup is maybe a little bit more flexible because you can change those rules outside of opening the code. To modify this enumeration, I'd have to go into the code inside a Data Factory, and I might have to issue a PR and a merge and, go through CI/CD process to do it. If the change is in a database table, it's much easier to make that change. So it's just something to keep in mind. Data Factory supports lookups for both cached and uncached data, by the way. So you can do lookups in real time or you can do lookups that you've cached. All right. Next category of data quality, extremely important, especially in Lakeland, where you're going to get lots of files of lots of common data over and over again. How to dedupe and make distinct rows. Make it super simple in Data Factory. I hope I get time to show you this because it's really easy. The top right looks complex, but don't worry about it. It's a template. You'll see the template in the bottom right. We have pipeline templates. You're able to just pick the tile that says dedupe pipeline, and we build it for you. You just plug your data into that process. This one is actually an example of a fuzzy matching. This is using SoundX. So for values in your columns that sound like another value that was maybe spelled slightly differently, it'll match anyway. I'm also going to show you the fuzzy lookup or the fuzzy join capability in the joins in Data Factory to make this even simpler. By the way, distinct rows is a little different. Distinct rows is actually taking the data as is without doing a fuzzy match on it and just saying, just give me all the rows that are unique. And that's very simple because you can hash columns in Data Factory to do that. So here's a look at the fuzzy lookups and fuzzy joins. The fuzzy lookup on the bottom right is using the SoundX that I mentioned. The top right is the fuzzy join capability in Data Factory. Super simple. You just use the slider to change your similarity threshold You give us the string columns that you want to match on, and you can do a full inner or left outer join on that data, and then we will apply the fuzzy algorithm for you. I would recommend using that quite often in your lookups against reference data in the lake when you can't guarantee the data quality on that reference data. Just keep in mind there is a penalty to pay in terms of performance using the fuzzy versus the straight lookup. It'll take a little bit longer. Okay, metadata validation rules. I talked about this earlier. I showed you the example of conditional split for bad schema and good schema. And I'm going to show you how to build a metadata validation checker in Data Factory. Super important so that you may want to many times before you kick off a job, validate that the data you're getting, that you're being given for your data integration, your ETL pipelines, is actually valid data. So no guarantees in the data. Instead, run it through a validation checker first. Last slide. That's good because I'm tired of talking about slides. We made all this super simple now in Data Factory. There's a new transformation that came out a few months ago called the assert transformation. Everything I just told you, I'm going to show you how to build it in Data Factory from the ground up. But it's even simpler if you use the assert transformation. The assert transformation does a lot of the data quality work for you. It doesn't do data cleansing. For that, you're going to want to do a derived column or do some other further downstream processing, which I'll show you. But an assert is useful for building data quality pipelines. You can log failed assertions to a separate file. You can fail fast. There's a button in the middle you'll see in the screenshot up here called fail data flow. Boom, as soon as you find something that does not pass your assertion, fail the pipeline right at that point. We have built-in expectations. So the word expectations is highly used now in the big data and the data lake world for data integration. Highly used in Python and in Databricks these days as well. So we kind of adopted the same terminology. You can expect that a condition is true. You can expect that rows are unique, and you can expect that a certain value exists in one stream and another stream. Those are all built in for you. You just give the rules to apply it. All right, that sets up what we're going to show, what I'm going to show in Data Factory, and how to do all those things. Hopefully, this resonates with you. These are things that challenges you run into. You've been wondering how to do them. And I'm about to show you, so strap in. Before I do, let me just ask if see if there's any questions out there. It looks like not. So just give me a second to have some lemonade.
Yeah.
That's because it's all crystal clear.
Yeah, there's nothing but lemonade in it, right? No vodka.
That's right.
Okay, cool.
Lemonade was no, that was pure lemonade. I'm in the office. All right, so let's take a look at, so just to set you up a little bit without going through the full sort of, what would take a whole day to talk about Data Factory. Let me give you a lay of the land and what we're going to look at today. So Data Factory, and by the way, there may be some things that you see in this UI that may look a little different in yours. I'm using the internal version of the UI that we sometimes have some pre-release of things on here. So there may be some things that aren't quite lighting up the same way for you, but they will eventually once we deploy. So there are 5 primary artifacts or factory resources that you're going to find in Data Factory: pipelines, data sets, data flows, Power Query, and templates. There's others like link services, data sets, and whatnot, integration runtimes that we'll kind of touch on as we go. The pipeline is the core primary elements of any Data Factory that you're going to run, and that is your control flow. Your pipeline has many different facilities in it, not just control flow. There's a really simple pipeline that I'm going to use. Oops, there you go. That I'm going to use today, which has one activity on it. It's going to run a data flow. The other activities are here in the toolbox on the left-hand side, and you can expand these to see all the different things that you can do with it. And it's control flow as well as the ability to call things from other compute services like Azure Functions and Data Lake Analytics and Databricks and whatnot. The control flow you're going to find under here on things like iterations and conditionals and in general. So you'll see for each lookups, get metadata, all those kinds of things available to you here. And you just snap those together on the design surface here and build out your workflow. Easy peasy. Now, the other thing we're going to talk a lot about today, a lot of the code I was showing you, a lot of the designs I was showing you was in data flows, what are sometimes called mapping data flows. So in the data flow, let me double click on this and you'll see my data flow here. This is similar to what you've seen in SSIS. Notice how the design surface is a little different. We use the acyclical graph style of snapping things together, the DAG style, for the designer on the pipeline. But data flows are different. Data flows are not workflows. Data flows are essentially code that allows you to do data cleansing and data quality, do slow change in dimensions and all those kinds of things. All the data transformations are here. So this is a snapping logic, essentially a construction logic, and you build from left to right. So you add a source by clicking on the source. The source transformation is always available to you on the design surface to add more sources that way. Okay, I think this is almost like your connection manager sort of thing that you'd have in SSIS. And then you attach the next transformation to the previous transformation. So you see a list of transformations are available to you in the toolbox here. And then when you snap together your flow, you can go inside of those and you can build your logic. So this is where you would build the logic that I was showing you earlier using the data transformation language called Dataflow script within ADF. That's pretty much it. As we go through, I'll talk about more of the primitives available to you in Data Factory. I just want to give you that understanding as we start to talk about how to do these things. So one of the easiest things to start with in terms of the different data quality initiatives we were talking about, I'm going to start with a Power Query. So what I'm going to do is I'm going to add a new Power Query activity. So you click on plus under Factory Resources and click Power Query. We're going to do this too. You can transform data through Power Query, of course, don't forget, and you can actually sync that data into a destination in Data Factory. All I'm going to use it for is for that today is just for that data profiling use case that I mentioned earlier. Okay, so I'm just going to pick a set of data. I'm going to use my movies is usually what I default to for data sets. And then what we're going to do is we're going to have turned on the profiling capability inside of Power Query. So once you add a Power Query activity, the Power Query UI takes over that space within Data Factory. And so there is it took just a few seconds. And there you see the profiling for each of the columns within my data set. The data set was built in Data Factory, but this is actually running it against the M service, the Power Query service, to give me the stats that I have around my data, the number of distinct values, unique values, how many are valid or how many have an error in it. And by the way, you turn this on by going over to options, and there is a global option that is for enabling the column profile. And showing the column quality in your viewer. So you can turn that off or on. If you're transforming a lot of data, you don't care about the profile stats, you can always turn that off as well. So that's how to profile your data in Power Query. That's all you got to do. You don't even have to run that, right? There's no running that as a pipeline. Just plop that into your pipeline and get a profile of your data. Now, if you'd like to do that inside of Data Factory without needing to have Power Query activity on your screen, you can do that too. The data flow has a built-in data profiling to it as well. So let me go over to one of my data flows here. I'm going to go over to, let's go over to, I think the one with names is going to be a good one. I think I have the under fuzzy join. I'm pretty sure this is going to be a good data set to use. So this is the data flow design surface. And at the bottom panel, you'll see each transformation has a configuration panel. I'm on the source transformation, which is getting the data from, getting data from Data Lake. And I'm using this fake set of HR data called names 1001. So under data preview, if I refresh, now by the way, data flows in Data Factory is running not on an SSIS or a proprietary engine, it's running on Spark. And so all the data as you collect it is stored into that Spark cluster in memory that is being managed by Data Factory. And so when I click refresh or I look at profile stats, what it's going to do is it's going to send that payload out to the Spark cluster. It's going to collect that data, and then it's going to return to you what the snapshot in memory in the data frame looks like. It doesn't actually write any data. No data is written when you're previewing it. It's only when you run it from a pipeline that you'll actually persist any data. But this is what my data looks like. So I can see all the different columns. I can sort by the columns. I can move the columns around. I can export it to a CSV if I want to explore it through Excel. You can also click on each column and you can say, give me the statistics. So this will give you the same kind of profiling statistics that you saw in Power Query. So this one's giving me the stats saying that the maximum length is 6. Note like this, every column in that, every row, every value in that column is exactly the same length. And there are 91 that are not null, so there are no nulls. And that's why you have the pie chart that's completed. There are no nulls in it. Let's take a look at the gender column, and we'll do the statistics on that one. Now you get the value distribution. The reason for that is because it's essentially a binary value. It's a F or M in this case for the sample data in here anyway is. And you see that we have 60.4% female, 39.6% male, and then we have the number of nulls and everything else on it. So you can get the same kind of insights in your data directly in the data flows from Data Factory if you don't want to have the separate Power Query activity to do that. Very simple. That's how you can profile your data. I had an existing data flow here that I showed you just to show you how you would get into this from Data Factory to get started. Under Factory Resources, just click New Data Flow. Don't worry about flowlets. Flowlets is a way to templatize your data flows. But you want to click a New Data Flow and then add a source. Point to your data. You're going to want you to have your data in the lake like I was doing there, or maybe a database. I've got a bunch that are in a database. Here's an address table coming from AdventureWorks. This is what my projection looks like from that database, and I can data preview from here. And then once you've got your data preview back from the Spark cluster, now you can play with it. You can do some, let's see, this is a numeric. The other columns we're looking at were categorical strings. Let's take a look at what the integer value looks like. Okay, so now you get the number statistics on it, the numeric statistics. You're seeing that the 25th percentile is 550, standard deviation is 897.29, no nulls, 50th percentile, 75th percentile variances, and so on. So you get the numeric profile of your data that way. This is how to get the depth of understanding of your data before you build your ETL. Very important aspect of data quality. Also notice I didn't run this. I didn't actually execute it from a pipeline. Did nothing like that. I just turned my debug session on. Dataflow debug is up here. Boom, I got a Spark cluster. Now I can go ahead and I can explore my data. All right, let's talk a little bit about the fuzzy joins. I'm going to go backwards a little bit here on the slides. I had fuzzy join toward the end, but I think it's very important to know, and I think it's really easy to use, and it's important to know how to use it when you're working with data that's going to be a little bit gnarly in the lake without the data quality that you might expect. And I do see a chat, so let me see if I got. Do you mean the Great Expectations package? Yes, Kevin, I do mean the Great Expectations package. Thank you. So I have two different sets of names. This names is called names 100, and this one is called 1001. Notice I'm joining them. Okay, this is my data flow. These select transformations are just pulling out certain columns. I'm using some rules for my column names, and I'm saying just give me the last name because I just want to show you how this works in a single column. So the overall projection, if you look at the projection over the inspect, you'll see the schema for the data. It has a lot of columns in it. We don't really care about all those for this demo. I'm just going to look at the last names. Let's match on last names aren't exactly matching. So in the data, I have these two files, and I've kind of mucked it up a little bit so that there are some similar spelled names, but not exactly right. Let me quick show you what it looks like. So I've done some funny things, like I named it Robinson. I spelled it with two S's here. I took Young and I spelled it with a J instead. I put a Z instead of an S for Flores. The other file will have the same rows, but slightly different spellings on it. Actually, you know what? I just realized I showed you that in Storage Explorer. I could have just shown that to you in the data preview. So let's do it that way. So this is the data preview. There you see the right spellings of these names. And then down here, if you data preview, you'll see some of the not right spellings of the names. But because we're saying fuzzy lookup or fuzzy join, ADF should be able to resolve those properly. So we're going to click data preview on the second source. Every transformation within your flow in Data Factory can be previewed. The data can be previewed in isolation, which gives you a good unit testing capability. So there's Robinson with two S's, and I spelled Bailey wrong and whatnot. Okay. Now, let's go over to the join transformation. Before we do fuzzy matching, let's just do a straight inner join between name 1 and name 2. And let's take a look in the data preview at how many rows are matched on that. By the way, the number of rows is 91. Okay, you get this data right from the data preview pane at the bottom in Data Factory. 91 rows. So when we join the two, Okay, we got all kinds of crazy matching going on because there are duplicate names, or there are names that are not matching at all. And so we don't get the result that we're looking for. If we change this join over to, let's say, fuzzy matching, let's do fuzzy matching at, let's do like 84 as our threshold. You can slide the threshold right here. Let's preview on that. Oh, by the way, I was checking to make sure we're getting all the rows. There is a debug settings in data flows. You can set the number of rows that you use for your sampling here when we're doing the preview. The preview is not going to read the entire source. It's only going to read the number of, it's going to limit the number of rows that you have set in there. Okay, there we go. So I set the minimum similarity score to 84 in my settings. And now we get, there was a set of 84. And the data preview, we got 80 rows matched back. And it'll tell you the similarity score right here. So these all match at 100. This one matched at 85.725. So there's why I misspelled Jackson, right? But it matched it anyway. Now we're getting the matching that we're looking for. If you want to be a little bit more, you have the choice as a detailed data engineer here in Data Factory. If you want to be a little more lenient with that matching, slide this all the way down. 60 is the lowest that will let you go. Let's do a 60 match, and then let's see what we get now. Now we might get some things that actually don't really match very well, but the engine will probably find it. And you'll notice it's going to take a little bit longer with a fuzzy matching than it would with a straight join. So we had 80 was the match number with 84 similarity score. Now we matched 7 extra rows came in. Now we matched things that were only 80%. So Baker and Raker matched. You may think that's good, and you may think that's bad. There's my Bailey misspelled, Scott misspelled. This one, I don't think I did, by the way. Okay, so that's an example of one that you are getting some false positives then if you go too low on your fuzzy matching. That's how easy it is to do fuzzy matching. Very important on your joins, especially with reference data inside of the lake. All right, we can close the fuzzy join. Let me not go to this one. Let me go to something a little bit simpler. So I mentioned earlier that distinct rows is extremely important, right? You don't want to have duplicate rows, and you will get duplicate rows a lot in the lake and in these ETL processes when you're building data factory pipelines. So we make it super easy to accommodate that. A couple of things you can do. If you want to get started and you want to apply these patterns to your processes, you don't need to build it from scratch. We have a pipeline gallery. Go to New Pipeline, Template Gallery, and you'll see all these samples and these galleries, these templates that we have out there in the gallery. So let me look for distinct rows. There it is. Distinct rows is actually a template. All you have to do is click it, tell us where your data is, and boom, you got a pipeline with distinct rows in it. Okay. Now this pattern is a little different than the one that I am showing you, but it's there for you in the template gallery today for you to use. I have actually a simpler one. Maybe I'll actually even update our template to use this new pattern. But all I'm doing in this new pattern is just hashing each column in the row. So there's a bunch of hash functions inside of Data Factory. And for this data flow, I used SHA-2. So I'm using this meta function called columns that'll give me the column value for every column in your data, which is great, which means it's completely generic. I don't have to know, it'll work with 1 column or 1,000 columns. It doesn't matter. It's going to create a row hash. And then all we have to do is we have to say that group those row hashes together so that you only get the unique values. That's how easy it is to do deduping, or essentially distinct rows within Data Factory. I have this, even though the template doesn't have this technique, I do have it in our documentation. So in our docs is, you'll see data flow script fully built out in here. And in the data flow script documentation, I do have an example of distinct rows. And what I've done is I've done it as a sort of a scriptlet or a snippet. And so you can take the distinct rows down. Here it is, distinct rows using all columns. So right here is that aggregate that I was showing you. You just click copy, and you have that on your clipboard, and then you can paste that right into your aggregate right here to get this exact same thing that I'm doing here. So I'll refresh this, but I don't think it's going to be apparent what it's doing because the there is some duplicate data in here. Okay, so I think I have some mocked up data. And there you go. So all of the data, all the movies that were duplicated in my data set are erased, are gone. And all you gotta do is just run it through here. And the way you'd add it to your pipeline is you would have a pipeline that maybe uses copy data to acquire some data, attach it to your data flow, and then dedupe it. And that's it. So this data flow would be your dedupe. And you'll notice that in this case, I'm using the data flow called assert1. I would just make this say distinct rows. Boom. That's it. So all of your duplicate rows will be eliminated from your data. Put this back to assert. Take this out. All right, so that's distinct rows. I'm probably not gonna have time to show you the full fuzzy deduping. So the distinct rows is great when it's exact matches. It's building a hash, a fingerprint for your row, which means every value has to be exactly the same. However, you could have, again, some dirty data where there's actually duplicates, but the rows aren't exactly named the same. Like you have maybe some fat figuring if the last names like I did in that data set that I was showing you. This is also a template. So if you go to new, pipeline, template, you will see a template for fuzzy deduping. And it's right here called dedupe pipeline. This pipeline utilizes fuzzy matching. That entire dedupe process you can add directly into your pipeline very easily just by using that template. And this is using SoundX. The book that I just published for mapping data flows has this example in it. So I walk you through how to build this if you want to build it from scratch. Just look at mapping data flows on Amazon. All right, so that is fuzzy matching. We did the, okay. So the next thing I'm gonna show you is metadata checker. This might be the last last demo that I can show you. The metadata checker is very helpful for validating that the files that you're processing or that any data source that you're processing has the schema that you are expecting. Data Factory is resilient to change, and it does that through schema drift. So let me show you what that means. Oops, I did not want to do that. There we go. Inside of my data flow, I can say allow schema drift. Schema drift is turned on by default. It's available to you both in the source and in your destination sync. You will have that ability. It's going to be down here. Pick a different sync one. It's actually writing to a data store. Right here. Allow schema drift. What that means is you build your logic based on a schema that you know. Or an unknown schema can be done as well. I'll show you that in a second. But you can also say allow schema drift. So if those columns change or new columns come in, just pass those straight through all the way to the end. And it'll work just fine. It's completely resilient to any change. Just allow schema drift. And that's on by default. You can always have a validated schema and turn off schema drift if you want to have a more hardened process, which is also a valid use case too. That being said, you may have values inside of those columns. So maybe the values change, or maybe there is a change in the number of columns that you want to account for. Maybe you want to say, hey, tell me when, or make this invalid when the number of columns is not equal to a certain number. So you'll see in this top section, I have this bad column checker. And I'm saying, give me all the column names, which is the column names meta function. That'll tell you each column name. And I'm saying if the size of that array, this is an array, is not equal to 8. So saying that if there is not exactly 8 columns, send this down the bad column count. If there is exactly 8, then it's good. And then I do this check down here. The second check that I'm doing in the metadata validator, which is my browser all of a sudden is getting hung, so I apologize for that. There we go. This is looking for a specific column name. So I had this example in the slides. I must have a minimum of this column in my data sets. I'm saying find by name this column in my metadata. If it's there, good. If it's null, it's not there, bad schema. What does that look like? Let's go ahead and let's execute this. This one I've not made into a template yet, but I will do that after this call. I will I'll probably publish that next week or the week after to our template gallery. It's a good schema. There are all good rows and no bad rows. So what you can do then is take this into a pipeline And you can just add this data flow to any pipeline and say, check this data before I process it any further. So it's going to actually use, this is the one I want because this is actually going to be the metadata checker. So let me do meta on my pipelines. It's this one that I want. There we go, metadata checker. It's going to call the metadata checker, and then it's going to read that return value. So I'm using an if condition then to say, by the way, you may not see this orientation for your container objects yet in your data factory, so don't worry about that, it's coming. So I can say that if, here's what my if condition looks like. If the number of bad rows is greater than 0, then I want it to go down this path. If it's all good rows, then it goes down this path. All right, so I'm pointing to moviesdb.csv. That should be a good file. Yep, let's go ahead and run that. So I'm clicking the debug button to run in place from a pipeline. Data factory, just click the debug button. You don't need to save, you don't need to publish or anything like that. You just click debug. And by the way,
Mark,
the reason, yeah.
10-minute mark, okay.
Oh, thank you. And the reason why, I could talk for days on this stuff. The reason why I can save, by the way, is because I'm hooked up to my GitHub. So make sure you connect your data factory to your GitHub. I recommend that to everybody who's using data factory. If you don't hook up to your GitHub, you're always publishing to our live service, which means everything has to be validated before you can do that. So let me let this run. Let me see if there's one more thing I want to show you while that's cooking. Yeah, I want to show you the assert. Very important to show the assert before you go. Okay, so this is running the metadata checker. It's now checking that file for all the validations that I showed you in that data flow. Let me let that run, and I want to show you one thing while it's cooking in the background. A lot of this is much simpler using the assert transformation, brand new transformation that we have, only about a few months old now, that allows you to set these expectations here. So I set 3 expectations in this one assert. I'm saying that I want all the addresses only to be US addresses. So I said my expression is country region must equal the United States. This is coming from AdventureWorks. I want to say that the address in my initial stream has to also exist in my second stream. So I'm doing it exists across 2 different streams of data. The third is a duplicate check. Make sure that there are no duplicate addresses in my data. So I just set these 1, 2, 3 expectations in my cert. Now what happens is when you look at that data, it will give you error indications that the asserts failed. So you can see in real time whether or not your assertions are going to be passed. Let me go back to the pipeline. Okay, the pipeline is done. So it ran through the metadata checker. The if condition said all good rows, and so it went to good rows. Now, if I were to run this again, but this time point to a file that does not have exactly 8 columns in it, which I know is loan.csv has many more than 8 columns. Let's run it again. Let's see what we get this time. Let me go back to the assert. And okay, these rows all checked. They're all Washington. They're all US. They're not duplicates. But we go down, we see some red checks. Okay, let's see. This one failed. This probably didn't exist in the other data sets. The same with these 2. If you want to know why, okay, these are not US. All right. Now, if you want to know why, you can go here into the sync and you can say, send my error rows to an output file. So all the rows that do not pass your data quality checks will go to an error file. I'll show you what that error file looks like now. So let's see, let's take a look at this one here. So what's going to do is it's going to give you the output of the errors as well as the reason it failed and all the original data. What's really nice about that is because you have the original data, you can run it right back through your processing engine, right back through the pipeline again. Oops, I clicked it twice. So here's what it looks like. There's all the original data, so you can reprocess it now, along with the message, only valid for US addresses. So my data quality rule failed, and it told me why. So that's the assert transformation. Maybe I should have started with the assert transformation because it's super easy. I wanted to get a feel for all the different things you can do in Data Factory though. Let's go back to that pipeline with a bad file. And I probably actually used the file that actually works, so it came back with good. Oh darn, that one failed. Okay, so what that should do, let me actually go back. Let me just take a look at this. Maybe I can show you that within the last 2 minutes here. we're doing the metadata checker. So if we say debug, I'm going to set a different parameter. I'm going to say loan CSV. Let's go ahead and refresh now with this file and see what we get. So this is always going to check your metadata and always going to check for whether or not it meets your data expectations. There you go, 1,000 bad rows. Okay, so in that case, you make that decision in your pipeline to say, no, I don't want to process this. It has bad rows. Last thing I'll show you real quick is within the assert. Another thing that's really cool about the assert, other than just logging the errors, you can actually say fail fast, fail the data flow. And so the way to handle that, the way to use that is to do something like this. Have your data quality rule through your assert. And then when I would make this say assert, check all of your metadata and all your values, and then have a script at the end. The script will actually write into an error log. Right? This is actually using the script activity to insert into an error log. So when this fails, when that data flow fails, because you set the failure in your data quality, boom, log that out through an activity. All right, I think I made it through everything I wanted to cover in super high speed. So I know it was a lot to consume. I'm going to put a lot of this info out there on our Twitter and on my blog, and I will post the links to it on the ADF Twitter feed so you can get some more information on it. And I hope that you found it useful. So let me know if there are any questions before we close up.